Welcome to lecture 11 on thermodynamics of materials. So we will discuss where we left off. That is, so features, okay, some important points continued. Important about the first law. Continued. The last one, you see, I said this maybe another one. The point, second point or third point? This is third maybe. Third. Third is this. Work interaction is up to who's that? Is of two types. Two types. What is this? Fourth. Make it fourth then. What is this? Mechanical work. A mechanical work interaction, that is PV type. We say PV type, pressure volume type. Another is non-mechanical. Okay. So what are examples? Examples of non-mechanical. Examples I am giving you. Okay. Example is surface work, electrochemical work, no, this is very bad. This is very bad. Okay, I have not actually not taken very lightly about this. No? You should have a more responsibility. You are actually absent yesterday, today. See, then you suck up this responsibility. You tell me career this I cannot because I have no actually no. This is very bad. Your teacher is inside and you are outside. A teacher have started class, you are entering. See, last day I actually know maybe one of them I actually asked to stand for a while there. Wait for a while. This I will do, okay, if I see. Don't expect that teacher will be late. You maintain your time. Since teacher may be late, okay, sorry. Surface work, electrochemical and work in presence of external fields. Now, so general form, I start this way, general form, this over, this is over. This important points I have actually noted, general form of the first law. This is actually normally not considered in books, but I will show you a full-blown expression. A full general form or right, a full-blown expression, equation, full-blown equation. What is this? I am writing this way, dq is du plus d phi I am giving you something I am writing, okay. First law I am writing you here, first law as we know, which is commonly known, which is widely known, which will be used actually finally, but that is what I told you yesterday, dq is du plus dw. This I want to generalize, give a general view, general form of this concerning other forms of work and energy. Follow me. Du is okay. d phi, this is actually d phi is actually is out of field, external field, associated with the external field, potential energy. This is the potential change in potential, okay, external field. Okay, let me write here better. Du dq, change in potential energy. These are all changes. Change in potential energy. Due to external fields. External fields. Then another one I am introducing, d kinetic energy. This is bodily motion. This is what? Bodily motion of the object, of the substance. Bodily motion, okay, of the body. So bodily motion. Kinetic energy is, as you have read in what? Read in mechanics. Kinetic energy. Newton's laws associated with this. Okay, what is this? Okay. Bodily motion. Okay, this is d. This part is dq plus d. This is the energy part plus work part. dq is du plus dw. Can I remove this part? I think this is dw mechanical. Mechanical, you know. I have written already two types, mechanical, non-mechanical. So mechanical first. Mechanical plus dw, let me write non-mechanical. Okay. So I am writing dw due to, dw, this I will give as prime. This is dw, this is dw prime, I will explain. This is non-mechanical. What? And associated due to fields. Okay. Due to field, I am writing short. Due to field, this field, dw prime with external field. Okay. Caused by the external field. External field, as I have already mentioned on the left hand side, right hand side, plus dw, another dw prime, non-mechanical. Primes are non-mechanical. Is what? It can be, okay. I have actually made it. So it is better, I'm sorry, it is better actually, I should write here, 2 minutes outside. Okay, dw plus what should I write? Let me remove this. No way. I will take it up. dw prime. This is actually, I would say, non-mechanical. This source, internal energy. What is the source for this non-mechanical work? On this side. Change in internal energy means internal energy. Source internal energy of the system. No field. Field I am taking up. So dw prime non-mechanical. Next is what I wrote. You write this back. What is this? I said source. Like in each case, write source. External field. And last you write dw prime, another non-mechanical, out of bodily motion, kinetic energy. Out of bodily motion or kinetic energy. Kinetic energy. Bodily motion. The whole body is moving. A train is moving. A ball is moving. This. So you are going to give a box here. So all kinds of dw, see, dq, du, change in energies, work done, dw. differential form. Is okay. Now I have to tell you something here. This is what is the types. I write. Let me write. Yeah. Again, I am explaining this. So this is known to you. PV type work. What is mechanical? Always mechanical means PV type. PV type work. Remember this. Sometimes I am repeating. Careful. Okay. I may not repeat. Source is what here? Internal energy. Example of this non-mechanical is 1, right? Right. Okay. Right. 1 A maybe electrochemical work. Electrochemical work. B surface work. What is this? What type of work? Okay. A external field, you know, gravitational fields. External field like, okay, shall I write here? External fields, like here. Yeah, complete this. Like gravitational field, electric field, magnetic field, external field and electric field. Here, so external fields, like say, so this is actually magnetic, as I showed, gravitational work. How many minutes? 3 minutes, 3 minutes, 3 minutes more. Gravitational, right? Magnetic. It field, these are the fields. See, tell me what it is? Electric. Get in. This is, what is this? Okay. This is bodily motion, already self-explanatory. That is kinetic energy. This is bodily motion, is kinetic energy. External kinetic energy. External kinetic energy. As you know, as I told you. So these are the things. Now here, further I will add something that I will explain further. This is non-mechanical, this is non-mechanical, this is non-mechanical. So write these three are non-mechanical work. Works. 3 types. Non-mechanical works. Okay. So internal energy, this. Then reversible form of, maybe useful, reversible form of the non-mechanical works of various non-mechanical works. What is the reversible form? One by one. Start. See, non-mechanical. Achha, you know, mechanical, you know. Can you remember what is the reversible form of this work? Reversible form of this work, mechanical. I am giving the reversible of this. But this is part of discussed. What is the reversible form of mechanical work? Means PV type work. Who said something? That is the general. Reversible is not general. I am asking. PdV. P external dV is the answer, and it is generally true. That applies to reversible as well as irreversible. That is the starting definition. So this you know, this is actually reversible non-mechanical work. Is what, at the end I will write that. PdV you should have known, but let me write, since I have started this caption. What is this? Quick, one by one. Electrochemical. Sometimes electrochemical work. What is this? DNFE. DNFE, from which you get NFE. DNFE. Okay, F is the Faraday, is the potential, DN is the number of electrons, change in number of electrons transfer. Electrical. So these are actually all write all dw prime. In the differential form, I am giving the expression. Just to get finite form, integrate. What is electrochemical? Then what is this? Next one is surface work. So dN is the number of, F is the Faraday, E is the potential against which the charge is passing. dN is the number of electrons or number of gram equivalents per gram mole. Surface work is what? Surface work is what? Tell me. Gamma dA. Gamma dA. Gamma is the surface tension. This is surface tension. This is Faraday. Okay, then you know this surface tension. This gamma is F is Faraday. You know this is surface tension. Surface tension or surface free energy. Third is what? Now these two are actually this category. Source is what? Internal energy. So we'll retain this. So later on, if external fields are absent, then we'll perhaps drop those terms. But start. This next is what? Complete this. Gravitational. So these two. Okay. Then gravitational. Gravitational work is what? You know? Yes. Gravitational is mg. H you knew. H you know, but it should be dH. Gravitational. Electric work would be what? I don't have space here. So go up. Right here, huh? Let us write here. Okay. Or shall I? Maybe better this side, huh? This side is there space, huh? This side. Then is what? Magnetic. Magnetic. Continue here. Here to here. Continue, huh? Magnetic work. Non-mechanical. All non-mechanical. What is the form? H. Magnetic field strength H. dm. Magnetic moment. The subscript m is the magnetic moment. mm is magnetic moment. Change in that magnetic moment. Change in the magnetic moment. You actually come across this magnetic moment when you magnetize a body, magnetize a substance. You increase the pole strength. You remember magnetic moment is pole strength times the length of the magnet. So increasing the pole strength, magnetization. So this work involved. Electric work is similar. E is the electric field. H is the magnetic field. H is what? Right? Will you write this? H is right. H is magnetic field strength. This you know quickly. Magnetic field strength. Then E. Electric work is E d. Electric moment subscripted E for electric. Okay, what is this? ME is what? ME is what? Electric moment. Electric moment, you know. And then E is what? Electric field. Is electric field. Electric field. Happy? So all covered. These are fields and kinetic energy, you know, this work actually. It can be expressed in different forms. Okay. But anyway, this is the thing. E is the electric field. This is called actually, this applies where? When you are charging a capacitor. This is relevant. With dielectrics, this is relevant. And per unit volume of this, electric moment per unit volume is known as polarization. Polarization. And magnetic moment per unit volume is known as intensity of magnetization. Per unit volume, if you want to, but keep it this form. Okay. So these are the things. So all the electric all covered. Yes, gravitational. Now here, in contrast, you may note this. Note here. Shall I write? It is better right here. Right here. Acha. Yes, from here. Double star. Right here. Maybe this is the right place. Recall. One thing you recall. What is that you recall? Hey, don't make any amusing things, okay? Outside. Lot of funds there outside. You can very easily land yourself into outside. Otherwise, I ask questions. Huh? What is this? DW mechanical is what? Tell me. What is your name first? Your name is what? Your name is, huh? Oh, I was yours, okay, this one. Oh, then you must be actually, have some rights actually to screw up here. Okay? So tell me, what is this? Mechanical work is what? Give an example. It is written here, mechanical. DW mechanical can be what? Can be what expression? Bringing your this smartphone not enough to satisfy the teacher. You have come here not for fun. Okay? I should actually spell out your name so that when people will hear, they'll know, oh, Ayush, you are that student. So you will be actually well known. You whispered? You whispered? Did you whisper that answer? Hello, I'm asking you. Did you whisper that answer? PDB what? What do you mean by PDB? What is the general form of mechanical work? Go back there and be attentive here. Okay? Two ways. Don't unnecessarily catch the attention. Okay? And bringing this one, helping with this one may not be enough. I may stop this. 20 students or 16 odd students were in the supplementary yesterday only. I told you this. Last year, my subject. Recall. What will recall? DW. A moment ago I was discussing, he was answering and I answered. And you took so much time. So you are not attentive here also. What to expect of the previous classes? A moment ago, he gave an answer and then a little bit corrected. DW, what is this called? DW mechanical. What is this? Since it is, I am writing at the end because this is, everyone is this well known to us because we have already discussed number of times. What is this? PDB. Recall. So all covered. Reversible form. Irreversible form can be. So give it. So this part is what? Surface work is what? Where it is relevant, surface tension gamma dA may be important. Where it is relevant, this I have already said. Okay, this is important. So let me write where suppose droplet formation, gas bubble formation. So where surface tension increase the surface area, then surface tension will be relevant and this term will be relevant. So surface tension. What is this? What is this? Then I say, oh, droplet formation. Droplet formation. Liquid droplet. Liquid droplet formation. There you use this term. Or gas bubble. Gas bubble formation. Happy? Why it is important? DNFE. Can you write? Where I wrote? Right. And why it is maybe why electrochemical is why relevant in EMF cells. EMF cell. This cell dry cells they are this. Okay. So EMF or electrolysis cell or EMF or stroke electrolysis, either way. Cells. So you get the importance, relevance, etc., and inclusion. Inclusion. Okay. So now I will actually edit this. This is general full blown. Probably you will never see this full blown expression in books. So what? Now, shall I remove this? Can I? Work with this. Now, In absence, we are in absence of external fields, what will happen? In absence of external fields, we metallurgists don't consider external fields. The chemical reaction, blast furnace reactions, steel making reactions, we don't consider in magnetic field or electric field or gravitational field, we don't consider. So, so it's very common. So we will easily discard. So let us discard. Then what it becomes? Tell me. dq is discarded, and kinetic energy, the whole thing is moving. That is for in internal mechanics. A train is moving, locomotive is moving, a ball is moving, a cricket ball is flying. Metal plus oxygen is metal oxide in a reactor. The metal is not running. Oxygen gas is not running with kinetic energy. They have kinetic energies, as I have said last year, that internal kinetic energy. Ruled out. So now you rule out. Now you will be satisfied that many forms of energies are included and their corresponding works. So you have satisfaction that I have not avoided. We have not avoided those terms. Included. Now, in absence of this, or you write yourself right, and external fields and kinetic bodily motion and kinetic energy. So this is not relevant to us, to chemists or metallurgists or chemical engineers or mechanical engineers. Kinetic energy, this is bodily motion. So easily exclude this. In absence of this, what is the form then becomes simpler, much simpler. Plus dw mechanical plus dw prime non-mechanical, and you know what is this? Please tell me, right? Mechanical then, mechanical quickly. What is this? Tell me what are the forms remaining? dw non-mechanical, prime. I use prime for non-mechanical. Remember, prime for non-mechanical. Prime sign, the sign prime actually used to denote non-mechanical works. Happy? Remember. So now tell me which. Let us see. Some of you who are actually expert, smart. This I will say once more. What includes this? What type of works this dw prime includes? Can anything be included here in the absence of this and this? Hello. Your name is what? Your name? Whispering person? Your name is what? Sachidananda. What is the? Is there anything remaining there? Smarter? Is smart guy? You are smarter. Okay. Funnier. Answer this. dw prime. You came late. What is this? Anything remaining there? dw non-mechanical? I am asking, I am following this class, okay? Is there, what are the forms do you think can be included here? What are examples of this? dw prime non-mechanical at this stage? Non-mechanical. So what else I am asking? I am asking here. Non-mechanical. Anyone? Yes. What are the types? Surface work, exactly. These are answers. Some of the students are very prompt. Follow the difference. You have missed last day's class, and when you come late, means every point you are late. You are catching up. When you are the time you are using for catching up, then another thing is taught. So you again catch up there. Always lagging. And already one important period you have missed because for your Delhi flight. Okay? So non-mechanical is right. So that's I am writing for you. Okay? What is this? Tell me. Surface work. Yeah, electrochemical first. Electrochemical actually is a subject you be taught. They are being taught perhaps. You're 1 year senior. That is called electrochemistry and corrosion. You have subject, there it is relevant. Okay, so you will be study, and surface phenomenon is very important. Absorption, okay, and okay, other surface, okay, properties, surface energy, surface tension. Okay, so electrochemical work, these are remaining, and surface work. Surface work. Happy? These are two things. Okay, very good. So shortened, at least shortened. Now I write something. Now further, it is not uncommon. Not uncommon to have electrochem work and I think I have already reduced, so I can remove this line. This line already discussed and it has been reduced to this stage. I am removing this. So it is not uncommon to have electrochemical work and surface work absent not involved in the system that we are studying. You are studying copper making. From ore you are producing copper or iron or steel. Where is the surface? Chemical reaction. We normally don't consider surface. Or if it is not actually electrochemical cell, like say electrochemical or electrolysis, you are not considering this. It is a high temperature reaction. There is no question. Okay. For any chemical reactions that you are considering, normally you don't, unless it is an electrochemical cell, it must be electrochemical. Maybe electrolysis cell or ENF cell. Surface work, as I say, where you will involve, say droplet formation, gas bubble formation, or okay, this gas bubble, okay, this blowing up of gas bubbles. Remember, with soap bubble, I have said, you create soap bubble formation. This is actually this field, surface work. That is gamma dA there. And increasing the area, become bigger and bigger surface area against the surface tension. That's why you are giving pressure. Relevant. But not, it may be possible that they are absent. And so, also a cyclic engine, cylinder piston. Adiabatic isothermal, what is this? This is very important because this will finally lead to cyclic engine. We speak of locomotive engine, steam engine, TV type, cylinder piston. What is this? What is this? So not uncommon. Okay, this is this thing. So what you are then ending up then if we consider not uncommon, so by dropping these two terms, what is then? I think I want your participation. I always constantly check. I waste time, but yes, I use don't look. Don't look. I use. If I drop these two terms, then what I get? Yes, correct. Tell what this comes. Say in words. dq is what? What remains? That you have to say. Delta. Oh, you are totally unbalanced. Only good. Oh, you have difficulties. You have many difficulties. Careful. 16 students in supplementary. And if they actually fail once more, the next semester with 1 year juniors. not enough. Helping with a smartphone, not enough. dq is du. What remains? So this drops though. So is it this? What I see, sir? You use your eyes, not so much intelligence. Sir, these are dropped. When they will be relevant, I will include. So that's what be a box here. This is important also. Absence of field and resulting relation is important. This is also important. Because this is metallurgical involvement. dq is dw mechanical. And when mechanical is the only source of work, when mechanical work is the only source of work, as you have understood, then why give any subscript? Then why, how it is written? Written du plus dw, only form, okay, it is the same. Oh, reconciled, call it equation, given equation 1 here, reconciled with 1. So you must be happy. Otherwise, you don't look away from me. Okay, then I will suspect. Okay, stare at me. Okay, but it is reconciled with 1. You understand? This is reconciled with 1. General. This is actually the popular, widespread, widely used. This is the equation that we consider as first law. But how? This is the genesis, the development. So you will be satisfied that, oh, sir, okay, now is everything okay. So can I remove all these things? Okay, so you back, you can give me another one. This part is, I hope, finished well. Now start. I'll actually consider, oh, by the way, sorry. Now you may call this, where I am using this fantastic equation, the first law of thermodynamics, a gorgeous, very important, universal law. Where I am using which system metallurgist? For example, applications. Let me write applications. You might be encouraged to note applications. One is all chemical reactions are use this. Yes, in absence. Only chemical reaction. No electrochemical. Only chemical reactions. And how many reactions are there? Infinite number of chemical reactions. You are studying, chemical engineer studying, chemistry studying, all chemical reactions. So this is the field you are applying, applications. Second is what? Phase transformation. Phase transformation. A chemical reaction, give an example, chemical reaction. Equation, FeO plus CO, FeO solid plus CO gas producing iron plus CO2. Give me an example, all chemical reactions. Second is what? Phase transformation. Example, sir, zinc liquid, zinc vapor. Third is what? Can you give another example that we have taught? Zinc liquid to zinc vapor. Let us say your name is what? I forget. Vidyut. Will you answer? Zinc liquid to zinc vapor is one example I have given. Any other example that I have discussed in the class? H2O liquid the other day. Most of the times the questions that I ask are easy questions. Remember this, note this, easy question. For student think it is a very difficult question. So things are vigorously think and bring out some actually this actually high level answer, complicated answer. So this third is what? Very important is what? Oh, solution thermodynamics, very important. Steel is a solution, as I told you. Steel, hot metal in blast furnace, the product is hot metals, all are solution. So solution thermodynamics. Fourth is what? Fourth is what I tell you? Expansion and compression of gas. Compression of gas in cylinder piston arrangement. In cylinder piston arrangement. In cylinder piston arrangement. Did you, your name is what? Your name? Somo. Somo, did you come across this? Fourth one. Have you come across this? That expansion and compression of gas in cylinder piston arrangement in this course? From the very first day. From the very first day, expansion and compression. Work done by the system, all such things. So, yeah. So, this is why this is important. You may ask back, why this is important? This will lead to cyclic engine, your locomotive engine, your Carnot cycle. This is the preface to that study. So important. So here in these 4 cases you will use this. This. So that's why this is so popular. All chemical reactions. Understand? Acha, by the way, can anyone? I am writing that. Acha, which leads to compression? Okay. As used in, tell me, cyclic engine. Cyclic engines, namely one important cycle is Carnot cycle. I am giving the name. Cyclic engine, Carnot cycle. This will come across. We'll study later. A locomotive engine, steam engines, all so important. So when your studies apply the first law, this is enough. For steam engines and other engines. Okay, go over. Can anyone tell me here something? 1 and 2? Anyone comment? One is chemical reaction and another is phase transformation. Are they 2 different divisions? What? They are same. As I told you, phase transformation is a kind of chemical reactions. As I told you, remember this. But I emphasize this point. That's why I gave this example. But it is a chemical reaction. As I said. Based on the second law of thermodynamics, phase transformation is not physical transformation. Unlike what you read in high school. No, forget. Can you forget? It's difficult to forget also. I know that it is difficult to remember something, but it is difficult to forget also. No, forget. It is a chemical reaction. Chemical reaction, you may say. Phase transformation is a chemical reaction, equal sign. Outwardly look different. Over, this part is over. Next is, as I was going to start. Internal energy. Quickly, let's get fast. Internal energy. Okay, this is the beginning, very beginning. Okay, and introductory thing. So you should learn very well. Ideal gas. Internal energy of ideal gas. I tell you what. First, you consider one monatomic. Monatomic. Example, e.g. what is the monatomic ideal gas? Maybe you consider helium, argon, inert gases, helium, argon, etc. Before I tell you what is the ideal definition of ideal gas, what is definition of ideal gas? So ideal gas is an assemblage of non-interacting volumeless particles. Very short definition and smart definition. So, it is an assemblage of non-interacting means neither attraction nor repulsion, non-interacting volumeless particles. So now tell me, if it is non-interacting, then ideal gas can have what is the potential energy of ideal gas? See, remember, internal energy is what? Recall, what is internal energy? This side. Whom I will ask? Irregular. You, can you answer? Internal energy is made of what? Last day's class. Last days only. You came late though, but you are present. Internal energy. Internal kinetic plus internal potential energy. Are these things, this knowledge bad, undesirable, unnecessary? It looks like you don't enjoy this. And she came later. Other day. Internal kinetic plus internal potential. So ideal gas also have internal kinetic and internal potential. Both ideal gas have. Ideal gas also have internal potential. Ideal gas do they have internal potential? No. You have what are you looking back? You don't. So you don't have. Do the ideal gas have kinetic energy? I mean, kinetic energy? Any kinetic? Ideal gas molecules have kinetic energy? Oh! So, unless you know, you cannot answer. You only fool around. You only mess around. Ideal gas don't have potential energies because they don't have attraction. Without attraction, no potential. I said potential means positional, you say. Position. This is the two molecule. Two atom, okay, two molecule of say an ideal gas, two molecules. They don't have any attraction. So either here or there is of no concern, no change in internal energy. But here, this body and earth, ground has attraction. So when it is here, some potential energy, here different, means greater, still greater. Positional, potential is positional. Change the position. Change the position, yeah. It doesn't matter whether they are here, two molecules here or here for ideal gas, not for real gas. Real gas have attraction between molecules. So one is off. So monatomic, so kinetic, internal energy. So internal energy, i.e., consists of ideal gas can't have potential energies. Because no attraction, no repulsion, no nothing. So only internal energies has actually generally kinetic energy and potential energy. So this is absent in ideal gas. Good. So only kinetic. Now start. Monatomic means I consider this. So remove all these things. Monatomic is, I say monatomic ideal gas. N, I say N is 1. Then you have, this leads to 3N. 3N, they use the term 3N, degrees of freedom. This is degrees of freedom, means freedom means modes of what is called kinetic energy. Modes, 3N. This is not phase rule, no, nothing to do. Here N is 1, 3N, 3 degrees of freedom, 3 modes of kinetic energy. What are they? Tell me. 3 modes of kinetic energy means what is this? Oh, okay. 3 modes, 3 degrees of freedom means 3 modes of kinetic energy. Since no potential energy, so 3 modes of leads to 3 modes of, tell me, kinetic is, okay. So, 3 modes of kinetic I have already written, okay. I have already written 3 modes of kinetic, no potential, okay. So, what is this? 3 modes is what? X direction, Y direction, Z direction, X, Y, Z, 3 directions. 3 directions. A body can move, a molecule can move in 3 directions. So 3 directions. Each direction, that's a 3. 3 and 3. These 3. Each direction, along each direction, the molecule has half kT of energy. Half kT. Each half kT. And this is also same. Each direction half kT energy. This is known, it's called equipartition, from the law of equipartition of energy. This can be obtained from the kinetic theory of gas, half kT. The term, remember, 1/3 mNc square, mNc from which you get half kT. So from the equipartition, from the principle of equipartition of energy, partition of energy theory, as given in physics, the subject physics, very important principle. Very good, thank you. Half kT, half kT, half kT. See, total 3. Happy? So total is half kT can be derivable. It's derivable, and it can be from the kinetic theory of gas. So PV is 1/3 mNc square. There you get this. Okay. 3/2 kT, and this is distributed equally in the 3 direction, half kT share. So 3 kT. So per molecule. So you write per molecule. You write here per molecule. One molecule is moving around, running around here. One molecule of argon gas. So it has 3 possibilities, 3 directions, and each direction half kT, associated with half kT of energy. So total, so please tell me next. Hence you tell me from this point. Hence, U is what? U monatomic. U monatomic is what? Tell me. Can anyone? Wait a bit. His name is actually Devapam will answer. So U monatomic is how much? Devapam, how much it is coming? U monatomic? Half 3/2 kT. Once more, I think K is Boltzmann constant. K is, remember, K is Boltzmann constant. You know this, but I repeat, it is R by N. N is the Avogadro's number. Avogadro number, and this is universal gas constant. Universal gas constant, the value you know. By the way, have I listed you this one? Okay, okay, very good. So K is, so it is Avogadro's number contains 1 mole contains Avogadro's number of molecules, so it is per molecule. And if you are interested, per mole, molecule and moles are separated by Avogadro's number. So times N. Okay, so it will be 3/2. U is 3/2 active per mole. 1 mole means 1 gram mole. If you are interested, mole is 1 gram mole. We says in short mole. So 3/RT. This is okay. So over internal energy is over. Actually 3/2 RT for monatomic, I think is okay. Very good. For diatomic next day. Today is actually. Do you have any class after this? Whose class? He arrived, okay. Stop. It's not good here. Stop today, okay. What is it? Oh, diatomic. You have stopped? No, 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 no. Quickly, diatomic. Acha, I finish this. Okay, Acha, close. Stop this. Okay, thank you very much.